Okay, so we're going to do the quadratic word problems, vertex notes. So the vertex is where an object will reach its maximum height. The x is the time that an object will reach its maximum height. The y is the height that the object reaches. So standard form of a quadratic we should know is y equals ax squared plus bx plus c. Vertex, y equals a times x minus h squared plus k. So the vertex of standard form of a quadratic is opposite b over 2a, which we've already learned. We know how to do this. Then to find the y, we plug in x to get our y. Then in vertex form, the vertex is really easy to find. Remember, it's just h comma k. All right, so looking at number 1, a baseball is thrown in the air with an upward velocity of 25 feet per second. Its height in feet after 2 seconds can be modeled by the function h of t equals negative 16t squared plus 25t plus 5. How long will it take for the ball to reach its max height? Then what is the ball's max height? So first let's find the vertex here. So I got to start with opposite b over 2a. So that's negative 25 over 2 times negative 16. So we're going to type that in our calculator. And it gives me a fraction. I'm going to convert it to a decimal using the double arrows. And let's round that to the nearest hundredths, 0.78. Okay, so then that was the x of our vertex, right? What we just looked at up here. So now to find the y, we need to plug the x in. So we're going to look at our original equation. And we're going to take our 0.78 and plug it in. So h of 0.78 equals negative 16. So in this case, I'm replacing all the t's. 0.78 squared plus 25 times 0.78 plus 5. So I'm going to type that in the calculator, negative 16 parentheses 0.78 squared plus 25 times 0.78 plus 5. So I'm going to round that to the nearest hundredth as well, 14.77. So this tells us it will take 0.78 seconds for the ball to reach its max height of 14.77 feet. And that answers our first question there. All right, let's look at number 2. While playing basketball over the weekend, Frank shoots an air ball. The function h of t equals negative 16 times t minus 1 squared plus 24 determines the height of the ball in feet as a function of time. What is the max height of the ball? So here, based off the equation, we know it's in vertex form. So I just have to look at my h and my k. So remember, your h is opposite. So your vertex here would be 124. So that's saying after 1 second, it reaches its max height. So the max height of the ball is 24 feet. And that's it. That answers that question. Okay, number 3. Miss Noon jumped off a cliff into the ocean. Her height as a function of time is modeled by h of t equals negative 16t squared plus 16t plus 480. How high did Miss Noon jump? How long did it take her to reach her peak? So again, we have to figure out, is that standard or vertex form? That's standard form of a quadratic. So to find our vertex, we're going to start with opposite b over 2a to get our x value. So negative 16 over 2 times negative 16. I'm going to plug that in the calculator. Negative 16 over 2 times negative 16 is 1/2 or 0.5. Okay, now I'm going to take that. That's my x value or my t value in this case. I'm going to replace every t with 0.5. So h of 0.5 equals negative 16 times 0.5 squared plus 16 times 0.5 plus 480. And we're going to type it in just like that. Negative 16 parentheses 0.5 squared plus 16 times 0.5 plus 480. And we get 484. So from that, that was our vertex. 0.5, 484. So how high did Miss Noon jump? How long did it take her? So my x is my time, my y is my height. So it took Miss Noon 0.5 seconds to reach her peak at 484 feet. Okay, on the back page is the everyday application. So establish your x variable and your y variable. The x is independent. This means that it can be chosen that there's no effect on this variable. The y is dependent. This means that whatever's chosen for the x will change what happens to the y. So let's look at this first one together. A company that sells tablets has found that their revenue can be modeled by the equation R of P equals negative 5P squared plus 1,230P, where P is the price of the camera in dollars. What price will maximize the revenue? What is the maximum revenue? So we want to find the price of the camera that will maximize the revenue. So our X would be the price of the camera, and our Y would be the revenue. Because this is our independent variable and this is our dependent, because when we think about it, the price of the camera affects the revenue. So let's go ahead. This equation is given to us in standard form of a quadratic. So we're going to start. We need to find our vertex. So we got to start with our x equals opposite b over 2a. So negative 1,230 over 2 times negative 5. So we're going to type that in our calculator. Hit your fraction button. And we get $123. So that's the max price of the camera to maximize our revenue. So we need to then take this x value and plug it back in, which in this equation, our x is like our p. Okay, so we have r of now 123 equals negative 5 times 123 squared plus 1,230 times 123. So we're going to type that in our calculator, negative 5 parentheses 125 squared plus 1,230 times 123, which gives us $73,165. So the price of $123 will maximize the revenue of $73,165. Okay, let's look at number 5. Although a football field appears to be flat, its surface is actually shaped like a parabola so that the rain runs off both sides. The cross-section of the field with synthetic turf can be modeled by the equation y equals negative 0.000234x times x minus 160, where x is the horizontal distance in feet and y is height in feet. How wide is the field? What is the max height of the field surface? So x would be how wide the field is. Y would be the height. So this would be my independent, this would be my dependent variable. Now looking at it, you might think, oh, it's in vertex form, but it is not. Our parentheses are not squared. So actually we have to distribute here in order to get it in the form of a quadratic. So let's go ahead and do that first. So y equals negative 0.000234 x squared. And then we need to distribute and multiply it by negative 160. So get your calculator, negative 0.000234 times negative 160. So that becomes plus 0.03744. Now I have it in the form of a quadratic, and I need to find my vertex in the form x comma y. So it's in standard form. So I got to start by doing opposite b over 2a. So opposite b is negative 0.03744 over 2 times my a, negative 0.000234. Be careful when we type this in. We have a lot of decimals going on. So when we hit our fraction button, negative 0.03744 over 2 times negative 0.000234. And then we get 80. Okay, so we just found the x of our vertex to be 80. Now the y of our vertex, we need to plug in all of our x, which here is in the quadratic form, to get our y. So we have y equals negative 0.000234 times 80 squared plus, and that should have an x on it there as well, 0.03744 times my x is 80. All right, let's type that whole thing in our calculator. So negative 0.000234 times 80 squared plus 0.03744 times 80. I'm going to round that to the nearest hundredth. So it's 4976. So I'm going to go ahead and round that to 7. I just went ahead and rounded mine, but of course your calculator would have said, just so you don't think you're wrong, 1.4976. I rounded to 1.50. So how wide is the field? What is the max height of the field surface? So the field is 80 feet wide, and the max height of the field surface is 1.50 feet. All right, last one, let's look at number 6. All right, so for number 6, the factory produces lemon scented widgets. You know each unit is cheaper the more you produce, but you know that the cost will eventually go up if you make too many widgets due to the cost of storage of the overstock. The guy in accounting says that your cost of producing X thousand units a day can be approximated by the formula C equals 0.04x squared minus 8.5404x plus 25,302. Find the daily production level that will minimize your cost. All right, so X would be the number of thousands of units of widgets, and then Y would be our cost. So it is in standard form, so we're going to start by doing opposite B over 2A. So that's positive 8.504 over 2A. So we're going to type that in our calculator. Go to your fraction, 8.504 over 2 times 0.04. So 106.3 is what you get for your X. And then we need to plug that in our X's to get our Y's. So our cost would equal 0.04 times 106.3 squared minus 8.504 times 106.3 plus 25,302. All right, so we're going to plug that in. 0.04 times 106.3 squared minus 8.504 times 106.3 plus 25,302. 24,850.01 rounded to the nearest hundred. So find the daily production level that will minimize your cost. So this is also the vertex, so that would be 106.3, and it's thousands of units. Would minimize your cost. Okay, and that concludes the back of our notes.